Imagine boarding a spaceship, entering coordinates to a star system 50 light years away, and arriving within moments. It's a dream straight out of science fiction. But could it ever be science fact? Faster than light FTL travel has captured human imagination for decades, inspiring countless stories, movies, and scientific debates. But the question remains, is faster than light travel actually possible? To explore this question, we must dive into the depths of physics, examine the structure of spacetime, and consider both established science and fringe theories. From Einstein's relativity to wormholes, from Alcubierre drives to quantum entanglement, we will journey through everything that brings us closer or holds us back from the ultimate cosmic shortcut. The speed of light in a vacuum is approximately 299,792 kilometers per second, about 186,282 miles per second. According to Einstein's special theory of relativity, this is the ultimate speed limit of the universe. No object with mass can reach or exceed it. Why? Because as an object accelerates toward the speed of light, its mass increases, requiring more and more energy to keep accelerating. At the speed of light, mass becomes infinite and would require infinite energy, an impossible demand. This principle has been tested in countless particle accelerators and experiments. So far, no known object with mass has ever broken the light speed barrier. But here's where things get interesting. While you can't travel through space faster than light, could you perhaps cheat the system by bending space itself? This is the idea behind the Alcubierre Drive, a concept proposed by Mexican physicist Miguel Alcubierre in 1994. The idea involves contracting space in front of a spaceship and expanding it behind, effectively allowing the ship to surf a wave of spacetime. Imagine placing a coin on a rug and pulling the rug. The coin doesn't move on its own, but it gets carried forward. Similarly, an Alcubierre warp bubble would carry a spacecraft forward without the ship itself ever moving faster than light within its local frame. Sounds incredible, right? But there are major issues. It requires exotic matter with negative energy density, something not yet proven to exist. The energy required may be comparable to the mass energy of an entire planet or even a star. It could violate causality and introduce paradoxes. Still, the concept is mathematically sound under general relativity, and some physicists are exploring ways to reduce the energy requirements. Another theoretical way to travel vast distances quickly is through wormholes, hypothetical tunnels in spacetime connecting two distant points. Einstein and physicist Nathan Rosen first proposed the idea, leading to the concept of the Einstein-Rosen bridge. These bridges would allow instant travel from one point in the universe to another. But again, we face major hurdles. Wormholes, if they exist, may be microscopic and collapse instantly. To keep them open, we'd need exotic matter with negative energy. Stabilizing and navigating them remains purely speculative. Still, in theory, if you had a traversable wormhole, you could reach another galaxy in seconds, without ever traveling faster than light in the traditional sense. Quantum entanglement has led to widespread speculation about FTL communication. When two particles are entangled, changing one seems to instantly affect the other, even across vast distances. Einstein famously called this spooky action at a distance, but experiments have confirmed that entanglement is real. However, entanglement cannot be used to send usable information faster than light, not in any way we currently understand. It's a correlation, not a communication channel. So, while quantum physics might hint at strange non-local behaviors, it doesn't offer a reliable method for FTL travel or messaging. Yet. In the theoretical realm, tachyons are particles that always move faster than light. They've never been observed and likely don't exist, but their properties are fascinating. They would have imaginary mass. As they lose energy, they speed up. They could violate causality and reverse time. If tachyons exist, they could potentially open doors to FTL travel, or at least suggest new physics beyond our current understanding. But for now, they remain a fun mathematical oddity. Even if FTL travel proves impossible, relativistic speeds, close to the speed of light, offer something almost as good: time dilation. According to special relativity, time slows down for an object moving at high speeds relative to an observer. This means that astronauts traveling near light speed could experience days, while years pass for people on Earth. From their point of view, they've reached distant stars quickly, even if light speed wasn't broken. It's not true FTL, but it's a glimpse of what's possible when time itself becomes elastic. Scientists and researchers have proposed several advanced concepts in hopes of making FTL travel more plausible. NASA's EagleWorks lab has explored warp field mechanics, testing tiny scale effects with laser interferometers. Dark energy might help fuel space expansion, a force already pushing the universe apart faster than light. Artificial gravity manipulation and inertial dampening are being theorized as ways to neutralize acceleration limitations. Still, these are early-stage hypotheses, far from being actionable. FTL travel would revolutionize our understanding of reality, but it might also break it. Consider these. Causality paradoxes. If you could travel faster than light, you might arrive before you leave. That could lead to grandfather paradoxes, where cause and effect are reversed. Multiverse theory. Some interpretations suggest FTL could shift travelers into parallel universes, avoiding paradoxes by branching realities. Simulation theory. Some argue our universe limits light speed to maintain consistency, like rules in a video game. If that's true, then breaking the speed of light might be like hacking reality itself. Mind-blown explosion. From Star Trek's Warp Drive to Star Wars hyperdrive, fiction is full of FTL travel. Here's what some popular universes envision. Warp Drive, Star Trek, based on the Alcubierre concept. Hyperspace, Star Wars, another dimension where light speed barriers don't apply. Stargates, Stargate, wormhole-like portals for instant travel. Fold space, Dune, folding the universe using mental powers and spice. These ideas, while imaginative, often serve more narrative function than scientific accuracy, but they inspire real scientists to explore what might be possible. If we could travel faster than light, the implications would be staggering. Colonize distant worlds in decades, not millennia. Meet alien civilizations, or at least search for them more directly. Escape planetary extinction scenarios, create interstellar economies, cultures, even wars. We would become a Type 2 or Type 3 civilization on the Kardashev scale, harnessing the energy of stars and galaxies. But with great speed comes great responsibility. FTL travel might be dangerous, unpredictable, or even ethically complex. So, can we travel faster than light? With current physics, no. Every experiment and equation confirms that light speed is the upper limit. But the universe has surprised us before. Black holes, gravitational waves, and dark energy were all considered fringe ideas, until we found them. Maybe FTL travel isn't about breaking the rules, but finding loopholes in the system, bending space, warping time, or rewriting what we think we know. Until then, we keep reaching, dreaming, and exploring. Because in the end, the desire to go faster, farther, and beyond isn't just about speed, it's about being human. Star, you made it all the way here, brain spinning, questioning if time is even real, and you're still not subscribed? Look, this channel isn't just content. It's a mental roller coaster through black holes, brain glitches, and bizarre theories your school never dared to teach. If you're into stuff that blows your mind and makes you say, wait, what did I just watch? Then yeah, you belong here. Smash that subscribe button so we can decode the universe together. Or at least get really confused trying. And hit the bell too, because if time is fake, notifications better be real. Let's get lost in the weirdest questions of existence. One rabbit hole at a time.